Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera. So in this video I continue chapter 4. Okay, this is the second part of the video. Make sure you already watch the first one. Okay, I want to discuss about forces between two parallel current carrying conductor. Okay, if you have two current carrying conductor that sit next to each other, it will have effects to the other current carrying conductor. So one conductor, when there's a current through it, will produce a magnetic field. Okay, example, if I have my current carrying conductor I1 here, and the current is flowing, or maybe I will discuss this one. Okay, so my I2, I have a current flowing in upwards direction. Okay, so this direction of current will produce a magnetic field, and this magnetic field, if you guys still remember, you have magnetic field on this side and in this side as well. Okay, but one side is going out, another side is going in. So you can take your thumb and you can try to double check lah. So everything over here is basically magnetic field going out of the page due to I2. Okay, so now you have a magnetic field on current carrying conductor 1. And if you guys still remember, if you have a current that flows in uniform magnetic field, it will produce a force. Okay, so you can use right hand palm rule and you can determine the direction of force, and in this case the direction of force will be in this direction. Okay, so that is one of the explanation lah. Another explanation is that you can try to watch a video here that I'm going to show you.
When both the conductors have current flowing in the same direction, the magnetic field in between the two conductors is created in the opposite direction. The north and the south poles so created attract each other, and the two conductors are drawn towards each other.
Maybe I'm going to rewind a little bit.
When the flow and attraction between two current carrying conductors. Magnetic field and attraction between two current carrying conductors. When both the conductors have current flowing in the same direction, the magnetic field in between the two conductors is created in the opposite direction. The north and the south poles so created attract each other, and the two conductors are drawn towards each other. When the flow of the current is in the opposite direction, we find the direction of the magnetic field for each wire as per Fleming's left-hand rule. We find that both the wires create the same magnetic field, that is, north and north or south and south, between them, and hence repel each other.
Okay, so that's another way of explaining the situation over here. Okay, it's up to you which one you want to understand, but the thing is, normally in assignment, the main things that you want to know whether it is attractive force or repulsive force. And the easiest way to remember is you have one situation where you have current in opposite direction, like I1 and I2 over here. You can see here I1 and I2 like this. It will be a repulsive force. So these two current carrying conductor will try to push them away. Okay, on the other hand, if you have in the same direction, you will expect to have, try to write over here, if I have I1 and I2 that is in same direction, okay, this is basically a current carrying conductor. So maybe I can try to draw it for you guys, because sometimes students missing out the point here. Okay, so if you have two current carrying conductor carrying current in the same direction, tak kisah dia ke atas, ke bawah, ke kiri, kanan, as long as both of these has the same direction, it will produce attractive force. Okay, so if you have opposite direction, it will be repulsive force, and you can simply memorize this thing. Even if you don't understand the explanation, my explanation and the YouTube explanation, you can still memorize this thing. Shouldn't be a problem. Biasanya dia tanya direction, simple things. Okay, but one more thing that you guys need to know is that how to derive the equation. Okay, basically the equation is this one. Okay, F, it should be F over L here. Okay, F over L is actually equals to mu naught I1 I2 2 pi d. So how do you get this equation? Okay, so to derive this equation, actually you can start with a very simple formula, which is F equals to BIL sine theta. Okay, this one is actually from previous subtopic. Okay, now the key important parts here is your subscript. It is for your reference, so even if you do it in opposite ways, as long as you get the answer, shouldn't be a problem. So it's for your reference lah. So here F12 means F on 1 due to 2. Okay, this is what I mean by F12. So the force at 1 due to 2. Okay, if I want to calculate BIL sine theta, the I here is obviously the current of the current carrying conductor here lah. So we are talking about this one. We want to find the force acting over here. The current that affect the force is actually this current. Okay, basically the I, you can ignore this I. Okay, but here you have to substitute B2. Why B2? Because the magnetic field on I1 here is actually due to I2. So that's why you have to use a formula to find B2 over here. Okay, and the formula will be B2 equal to mu naught I2 over 2 pi d. Okay, this one in chapter 4.2, early subtopic. So what you can do now is that you can substitute inside here, and you should get something similar to this. The reason why I put D over here is actually it is a 2 pi r, but since the distance from the I2 to I1 is basically just in this case is a D lah, so I substitute D inside here. Okay, so you can rearrange and you will get to this one. So the things about this equation is that if you want to calculate the force acting on I2, you can use the same formula, basically just flip I2 and I1 je. So because this one is multiplication, so shouldn't have any problem at all. So that's why you can write F12 is equals to F21. Notice that here, when I write over here, I do it over L. This is what we call force per unit length. It could be Newton per meter, something like that. It depends on the unit. Okay, another key thing is that F12 is actually equals to F21. It's sama. You can try to calculate if you don't believe lah. So the only thing is that you just change the position of I1 and I2. Okay, if I want to calculate at I2, I can follow the same procedure, and maybe this time you can try to refer it yourself. Okay, and then this one is repulsive force. Okay, so I'm going to choose example from past year, which is 2014 and 2015. They give you current carrying conductor sitting next to each other in parallel. The current direction is in opposite direction. One is going up, another one is going down. So here maybe you can straight away write it is a repulsive force from this diagram there. So this one is a repulsive force. So you know that if you want to calculate force over here, it will be to the right now. Over here it will be to the left, but this one is repulsive force. Okay, question number 1, they want to determine the direction and magnitude of the net magnetic field at the point midway between the wires. So the question asks you to find over here what is actually the values of B net. Remember, it's actually B net. So to solve that one, you can do it one by one. You can use B equals to mu naught I over 2 pi r. So here I'm gonna, maybe I can label I1 and I2 so that it will become much clearer. So the R here is actually the distance from the object towards the towards to that point. So this one you can divide by 2, it will be 6 centimeter. Okay, so if I substitute my equation here, I will get 4 pi times 10 negative 7. My current is 3.5 divided by 2 by 0.06. Why do I change to SI unit? Because you have mu naught. Mu naught is actually a constant. So you can press your calculator, and I think this one you will get B equals to 1.167 times 10 negative 5 Tesla. Okay, this one is actually I calculated for B1. Okay, we have to determine the direction. Okay, so magnetic field due to I1 over here in the middle there, you can try to use right hand grip rule. You will get that the direction of B over there due to I1 is actually going into the page, and this is B1, and B2 is also in fact into the page. Okay, so B1 you answer, and maybe you can write into the page. Okay, if I want to calculate B2, so I can use the same formula, and since all the values is the same, including the distance and everything, because it is actually at midway, I will get my B2 equals to 1.167 times 10 negative 5 as well. And I can add up these two because both of this is into the page. So maybe you can calculate B net. In this case would be B1 plus B2, and it's basically 1.167 times negative 5 multiplied by 2. Here I got my answer 2.33 times 10 negative 5 Tesla. Okay, so this is how you solve this kind of question. You have to identify what quantity that they actually ask. In this case they actually ask you to find magnetic field, net magnetic field, and then you can calculate, but make sure you determine the direction. Okay, itu yang key important part. Equation number 2, calculate the magnitude of the net force per unit length experienced by the wire. So you can go back to the equation. F equals to L equals to mu naught I over 2 pi d. So this is question 1 and this is question 2. So now again it's basically just substituting the formula. So it will be 4 pi times 10 to the 7 okay, and then I1 is actually equals to 3.5 and 3.5. divided by 2 pi. Now it's about the distance between the two current carrying conductor. It will be that one. Okay, everyone, I want everyone to press your calculator. Make sure you get the same answer. Kalau salah, tolong betulkan saya. Okay, I got 2.04 Newton per meter. Okay. Okay, I think I'm gonna stop here for now. Thank you.